Today we're going to look at one of our algebra topics. So we're starting to talk about polynomials. Today we're going to talk about polynomial addition and subtraction. So when we're adding polynomials, we can only add what are known as like terms. You may also be familiar with the phrase similar terms, and these are the same thing. So like terms are terms that have the same variables raised to the same power. So polynomials are added by combining these like terms. So an example of like terms would be something like 5xy and negative 3xy. Okay, so they have the same variable portion on the end with the same exponents. Another example would be 7x cubed and maybe 2/3 x cubed. Okay, so the numbers in the front can be different, but the variable parts have to be the same. So an example of something that are not like terms, let's say we have 3x squared y and negative 5xy squared. So if we take a look at the exponent, notice here the x is squared and the y is not. Here the y is squared and the x is not. So those are not similar and they can't be combined. All right, so let's look at some of these examples. Now if we look at the parentheses on here, we notice that there's nothing in front of them. Okay, so technically there's a 1 here and a 1 here, but we don't write that. Now to get rid of parentheses, we're supposed to distribute, but if we multiply through by positive 1, nothing changes. And if we multiply through by positive 1, nothing changes. So the parentheses are used just to differentiate the two polynomials. Just to show that we're adding two different polynomials together. So this is your first one, this is your second one. So all you have to do is find your similar terms. Okay, so notice both of those end in x cubed. So I'm going to say 6 minus 4 is 2. So that's going to leave me with 2x cubed. Now if I move down to x squareds, notice I only have one. There's an x squared here, but no x squared over there. So that one I'm simply going to bring down. There's nothing to combine with it. And same thing with the x term. There's only one x term there, so I'm just going to bring it down. All right, and I kind of ran out of colors, but we can see we're going to end with our constants. So 3 minus 7, that's going to give me negative 4 or minus 4. All right, so if we look at number 2, it's the same thing. They just went ahead and took care of the parentheses, so the parentheses are gone. So we're going to start by looking for common terms. I tend to start with the biggest x. I'm going to start with the x squared. Notice we have a negative 4 and a negative 8. So I'm going to add those to get negative 12, and I'm going to keep the x squared. Then we move on to the x terms. So this is going to be 3 minus 10, which is negative 7, and we're going to keep the x. And then finally we move to our constants. So 6 minus 1 would give me positive 5. So we tend to put polynomials in what we call descending order, where we start with the biggest exponent and go down, and then we end with the constant. Now there's a lot of examples on here, and I don't want to do all of them, so let's just go through and look at a couple more. So let's go back up to number 5. Again, the parentheses are not necessary because all we're doing is distributing a positive 1, and that doesn't change anything. So you can go ahead and start combining. So if I go back to my highlighter this time, I'm looking for squared terms. Okay, so that's going to be 17x squared. Then notice I have y terms, so I have a plus 3y and a negative 10y. So 3 minus 10 is negative 7, so that'll be negative 7y. And then I have z's. So this one is a negative 1, and this one's a negative 2. So if I put those together, I get a negative 3, and I keep the z. Now if we have more than one letter, there's not really a descending order. It doesn't really matter what order you put those in. All right, so let's do a couple more. I'm going to skip down to number 7. All right, so once again we have a plus sign, so the parentheses don't really mean anything, so I can start looking for common terms. So here we have an x, y, z. And if we come over here, we have another x, y, z. So 8 minus 2 gives us 6. We have 6 x, y, z. Now when I move over to my next one, I see an x squared y. And I don't see another x squared y. So I'm just going to bring that one down. Negative 3x squared y. And then finally, my last ones have xy's, so that's going to be positive 5xy and positive 1xy. So notice I always take the sign that goes in front of that term. It goes with it. So that'll be plus 6xy. At this point, none of these are similar, so I'm done. I cannot go any further. All right, let's try number 8. This time we're adding 3 polynomials together. Once again, when we see these plus signs, the parentheses are not necessary, so we can ignore them. So I'm going to start by collecting x squareds. So I've got 3 plus 4 is 7. 7 minus 5 is 2. So 2x squared. Then I move on to my x term. I see a plus 2x, but I don't see any more x's anywhere, so that one's just going to come down and be plus 2x. And then I'm going to end with my constants. I have a negative 8 and a positive 7. Together that gives me a minus 1. So I only have x's in this one, so I want to make sure to do that descending order. Let's go ahead and pick one more to do. Now if I look at number 3, no parentheses there, so if I start looking at this, I don't really see any similar terms at all. So the only thing I can do with this is rewrite it in descending order. So I'd write the 3x to the 4th first, then I would bring down the plus x to the 3rd, then the minus 6x, and then the plus 8. Okay, so not really combining anything, just rewriting that. All right, and that is all you have to do to add polynomials.